lecture series on industrial energy efficiency and its assessment methodology. Today we are going to cover the topic energy assessment on electrical utilities. In the first lecture, we got introduced to the importance of energy efficiency, focusing on India's energy usage, role of industries in energy consumptions and emissions. We also covered decarbonization, India's net zero targets, energy conservation strategies, audit protocols, and we also covered the career opportunities in energy management, including the BE certification for energy managers and auditors. For today's session, I invite the delegates from the Energy Consortium team, PALS champions, and all the students and faculty of PALS Partner Institute. A quick reminder, I know I'm going to be repeating it again, but I think it's worth it. A quick reminder, if you have the Zoom name with just your name, please rename it to have your college short name also, and make sure that the same thing is there in your Slido as well. Because when the leaderboard, the name gets published, it comes with the college short name. It will help us identify you easily. As I have mentioned earlier, participants will stay muted. You will not be allowed to chat, but that doesn't stop you from interacting. We have publishing a Gmail ID, askpalspmo@gmail.com. Write your queries, write your mail, concern, whatever it is, please write it to this mail. This mail is being monitored throughout the session. The other quicker way is you can raise your hand and I will unmute you and you can speak and ask your question. The attendance link will be pasted in the chat box by Robin. Make sure to mark your attendance to make sure that, the attendance for the session is recorded. And the Slido link will also be pasted, and please register in the beginning of the session itself. That will save us some time at the end. As usual, the feedback link, recording, and the presentation material will be shared post the session. So with this, I now invite Mr. Ravi Venkatraman, PALS champion, to introduce the speaker and the topic for you.
Yeah, thank you, Sujata. Can you hear me?
Yes, Ravi.
Yeah, good morning to all the PAL students and the faculty and our speakers, Mr. Sai Ramana and Jay Prakash. First of all, thank you very much for having come and attending this session on a Saturday morning, especially a holiday weekend. But I can assure you that this session is going to be very interesting, very relevant, and will offer you fantastic opportunities in your career. Today, the session is going to be an assessment on electrical utilities, followed by assessment on the other things because we have session 3, 4, and 5. But this is the first session, which is now more electrical utilities. So it is, even though it is relevant for all the engineers, but it is probably more relevant for all electrical engineers who are attending this lecture. So this lecture today, it does cover the topics on sanctioned demand, connected load, demand management, power factor, power distribution, power quality analysis, harmonics, transformer, load balancing, active, reactive, and apparent, power, cable losses, electrical line diagram, motor, types of starters, motor specification, types of motors, energy efficiency rating, international energy efficiency levels, power clamp meters, tachometers, lux meters, motor performance analysis, slip, types of belts, lighting and ceiling fans. Yeah, the list looks extremely long. I hope that we will be able to complete all these things within the given, 120 minutes or whatever. And our first speaker today is Mr. Sai Ramana, who is an energy assessment engineer in IEAC. He has a master's degree in energy and environmental engineering and 2 years of hands-on experience. He specialized in detailed energy audits across diverse industrial landscapes, turning data into actionable insight for optimized energy usage. Our speaker today, the second speaker, is Mr. Jay Prakash, who is an energy assessment engineer in IEAC. He has total 4 years of experience including 2 years as an engineer in the textile industry, 2 years as an assessment engineer at an industrial energy assessment cell, IIT Madras. He had developed strong expertise in both electrical and mechanical utilities, along with a solid understanding of thermal systems. So these two guys are going to talk to us today over the next probably about 90 minutes, followed by a quiz and then the usual question answer session. Hopefully we want to complete the session by about 12:30. So I won't take more of your time. Only thing is this is very important because it does offer you a lot of opportunities, especially job opportunities in all parts of the world, not only in India. This is one of the hottest areas today all over the world. People are all worried about energy, conservation, energy audit. So, I mean, if you do it, if you do the certification, you can find a job in any part of the world. With this, let me now hand over the mic to Mr. Sai Ramana. And Sai Ramana, all yours.
Thank you,
Thank
Ravi.
you for the quick intro about our team. Yeah, like, ma'am, do I need to keep the video on throughout the session, or like?
It will be better because if there is no problem at your end, because we are recording it and it will have a good view when we see the recorded video.
I'm like, I will turn on the video as per now. Like, if I face any network issues, then
Please
I'll go
do
for
that.
that.
Please, yeah.
Yeah, sure. Let me share my screen. Please allow me to.
Perfect.
Okay. Okay. Yeah. Good morning to one and all. Gathered here for the session. Like before, like day before yesterday, our team member has started this lecture session on giving a brief introduction about the energy assessment and the opportunities in this energy field. Let me start with the I will continue with the lecture 2 on the topics such as energy assessment on the electrical utilities. Let me start with the basics about energy. Energy is nothing but the ability to do work. In other terms, we can say the power to make things happen. For an example, you can consider shifting an object or lifting a load or heating things up. Everything requires energy. If you go for the stages of converting energy into several forms, let me take an example. From the oil till the electricity conversion, it takes around 5 to 6 steps. Like if you go for more and more number of conversion stages, each stage will have a efficiency drop. As precise as the conversion steps are, the more efficient you will be getting the energy converted. Then coming with the grades of energy, broadly we can classify the grades of energy into two categories. One is high grade energy and the other is low grade energy. The high grade energy can be utilized to the maximum efficiency. Like if you give the 10% input to the maximum, you will be getting the output. Coming to the for an example, you can think of electrical energy. Then coming to the low grade energy, you can't expect the more efficiency from that low grade energy. Also, it will be very difficult for you to store the low grade energy and reuse it at a later stage. For example, you can consider the heat energy. It has a lot of tendency to escape as earlier as possible. So, storing such energy is very difficult. Also, if you convert the heat energy to some other forms of energy, the efficiency will be little lower compared to the high grade energy. Our major topic is related to the electrical utilities. Let me start with the sources of electrical energy from which we will be getting the electrical energy generated. Initially, the currently the market is dominated with the fossil fuels, where the power plants are used to generate the electrical energy. Then nuclear energy is there, hydro power energy is there, solar energy is there, wind energy is there, geothermal, biomass. All these, like other than the fossils, the rest of the thing that I have mentioned here comes under renewable categories. Like coming to the biomass, it is also it is a kind of renewable energy, but the way how we handle it makes it pollution free or sustainable. Then coming to the distribution of the electricity that we have generated at the station or the power plant. There are various losses involved in the distribution of the energy generated at the generation end, then till the end, or like if you can consider the industrial user or at the domestic user, there are several stages involved in distributing the generated energy, and also several losses involved in that. You can see here thermal plant efficiency. That is the utmost starting point where you will be generating the electrical energy, like the heat energy or any form of energy that will be converted into electrical energy. In that, initially you will be getting the efficiency range from 28 to 35% only. Then you have to step it up to higher voltage. Then it has to be transmitted. Then like after the transmitting the high voltage transmission for the longer distance, you will be having substations at like regular intervals of time, or as per the requirement of the customers, the grid will be planning that. Then a high voltage transmission lines will be there, followed by that sub transmission lines, where the high voltage transmissions will be like getting prepared for the like distribution to the user end. Then from the transmission end, it will be going to the distribution end, where it has to be stepped down. And as per the requirement of the utilities, or as per the requirement of the users, either domestic or industrial, it has to be stepped down to the particular voltage. Then it will be provided for the utilization of the user end. If you consider the overall efficiency, we can quote a term called cascade efficiency, where it will be accounting the all the efficiencies from the generation end to the distribution end. We will be getting the final overall efficiency named as cascade efficiency. There is a like saying in the energy term, the one unit saved at the user end will be 2 units generated at the substation, or like the generated station. This comes from this cascading efficiency only. After the distribution, like after the power has been transmitted to the distribution end, the users will be having several lot of equipments at their end for the utilization of electricity, in which the equipment's efficiency will be poorer, or due to the operational patterns, the utilization or proper utilization of energy won't be there. So comparing all these factors, we can consider the cascading efficiency as 50% at the utmost point, like where we will be utilizing the energy in like as a output. Like for an example, you can consider pumping a water. That will be an output, utmost output, that you have generated the electricity and you have transmitted it to the user end, and you have used it for the pumps. You can relate it to it. In between, lot of efficiency drops will be there. Finally, you will be getting almost 50% of efficiency that is generated at the end as used as the source for pumping the water. That's why we say, like save 1 units of energy at the user end will be leading to saving of 2 units of energy at the generation end. Like I just want to have a quick question here. Why transmission voltage is always higher? Like why the transmission happens at a higher voltage? If you guys have any answer, then you can give it in chat box. Like I am expecting like 1 or 2 answers, then I can start like go on with that.
The chat box is enabled. You can use the chat box. The question is flashed on the screen. You can give your response on the chat box. Okay, I'm getting some direct messages. It says minimize loss, less loss, losses is less. There are some responses that are coming. You can see it,
Yes,
Mr.
ma'am.
Sai Ramana.
Like I have got like one or two responses. Also, ma'am has said that she got a direct message. Yeah, okay, fine with it. I'll go with the slide.
Good.
Yeah, the answer that you have said was exactly the same. The transmission voltage is always higher just to reduce the power losses. If you won't reduce the improve the transmission voltage, then amps like the current will be higher. If the current is higher, then I square R losses will be higher. If the losses in transmitting the power is getting higher and higher, then it will be difficult for the for fixing the economical cost and also for the generation. And like if they generate some 100 units, then you have to get like good amount of quality at power at the user end. If more amount of energy has been wasted at the I square R loss, then it won't be feasible for generating and transmitting. That's why they have using higher voltage in the transmission. And also for if the current capacity is getting higher and higher, then the conducting wires has to be designed for such. So the capex cost will also be increased. That is also one of the reason. You can brief this in 2 points, to reduce the power losses and also for the capex cost minimization by optimizing the conductor cost. Then let me go to the types of power. We will be usually we'll be talking power in these three terms. Active power, that is the amount of power, amount of quantity of energy that is exactly used for getting the work done. Then reactive power. Reactive power is used to create the electromagnetic fields that will be creating a situation that active power will be doing the actual work done. Together, this we will be considering it as a apparent power. And this is the power supplied by the utility for performing the specific task in a perfect way. This is also be said as vector sum of active power and reactive power, which is known as apparent power. The active power is measured in watts, then reactive power is in VAR, and active power is in kilowatt amps, ampere. We will be measuring it. And then the major criteria after knowing these parameters were how the billing is done for the energy that we are using at the industrial side. Majorly, the energy cost is divided into two major categories: demand utilization cost and then energy utilization cost. These two parameters have been will be billed in the energy bills from the grid separately. The demand utilization cost will be billed as per the KVA. They will be quoting an amount specifically for the demand that you are getting it from the grid. And then energy utilization cost is taken in two forms, like INR per kilowatt hour or INR per kVAH. Then coming to the demand charges, these three factors plays a major role: the contract demand, on the maximum demand, maximum demand, and the billing demand. I'll be explaining these terms in the coming slide. First, let me start with the energy utilization cost. The exact amount of energy that we are utilizing at the user end for doing our task. This is known as the energy utilization. The cost that is charged for this is in two categories: kilowatt hour billing. That is the real power that exactly we are using it. That will be directly considered and billed based on kilowatt hour. Then the advantages of this kilowatt hour is it is very simple to understand. Even if you see the Tamil Nadu grid board's domestic bills, you will be getting to know about this kilowatt hour only. They will be directly giving the difference of meter readings and for the duration of 2 months, how much kilowatt hours you have consumed, and directly they will be multiplying it the factor of unit cost, and they will be giving you the amount. It is directly related to the energy usage. Whatever you consume, then you will be pay for that. The setbacks or the problems with it is the power factor is ignored in this type of billing. And also, like, if the power factor is ignored, then there won't be any incentives for the power factors also, obviously. The second method of uh, charging the energy utilization cost is kVAH, kilovolt ampere hour billing. This is measuring the apparent power, like the combining the active power and reactive power. Mostly in the domestic side, kVAH billing won't be there. In the industrial side, some states follow kVAH billing and some states follow kWh billing also. Presently in Tamil Nadu, they follow kilowatt hour billing. In the kVAH billing, they will be considering both the powers, active and reactive power. It also relates with the power factor. If you maintain the power factor in a very poor way, then even if you consume lower real power, then the kVH will be improved to the ratio of that power factor. So the kVH will be quoted as high. So the benefits of giving this kVH billing at the industrial side is it encourages the power factor management. It will be insisting the industries to maintain the power factor. And also for the utility providers, it will be good. Like if we start consuming more amount of reactive power and if we are paying only for the real power, then the utility will be affected. Like they will be generating more power and power, but you won't be paying the exact amount what they are delivering for you. So it will be fair for the utility providers if you consider the kVH billing. And also it has a relation with the demand also, the contract demand also. So it will be reflecting in the grid impacts, the sensitive, how much stress the grid is undergoing, what is the load on the grid. The setbacks or cons with this kVH billing is it is somewhat difficult for the non-technical persons to understand how the billing has been made. And also, if you are maintaining power factor at a very poor state in your user end, then you have to install power factor correction measures that will require some amount of cost. Like even if you invest that amount for the power factor correction, you will be getting that amount compensated in terms of kVH billing. Though drastically the demand will be reduced and you will be getting the benefit instantly. And then the other charges, the energy utilization charges are completed. Then coming to the demand charge, there are three main terms in the demand charges: contract demand, maximum demand, and the billing demand. Contract demand is the demand that the user is giving an application to the grid that we will be consuming this amount of demand from the grid. As a agreement, they will be planning it. There will be a mutual agreement between the grid and the user, and that they will be consuming this much amount of kVA every month from the grid. And also the agreement says that if the contract demand is going beyond that kVA limit, then penalty will be levied on the user end. Then coming to the maximum demand, it is usually checked for the period of 15 to 30 minutes in a billing cycle. Every 15 to 30 minutes, they will be checking the maximum demand, what is the maximum kVA that has been uh, going for at the end of user. Then they will be concluding it at the end of month, that what is the maximum demand that has been consumed. Like the in reality, the maximum demand has to be less than the contract demand, so as we can avoid the penalties. So then coming to the billing demand, the billing demand usually is under either or condition. If you set a contract demand for 1000 kVA, then the billing demand will be in the range of 750 kVA to 900 kVA. If your maximum demand exceeds the 900 kVA, then you have to pay for the amount that is going beyond the 900. If if you are consuming only 600 kVA, then you have to pay the limit that is set by the billing demand, either 80% of the contract demand or 90% of the contract demand. You have to pay the grid as you promised in the agreement. Then coming to the connected load. This connected load is the major factor for determining this contract demand. Like if you know what are the utilities that is there at your industry that is connected to the electrical grid, and you will be using it for the production or any activities, then you can plan for the contract demand. For example, the major things to be considered here is the exact brief about this contract load is it is sum of rated capacities of all the equipments that is present at this industry. It also explains about the theoretical maximum, that if all the equipments at the industry operates at the same time, what is the maximum contract demand that can be reached by the connected load. It also used for the infrastructure planning. Like if you are having an 1000 kVA of connected load, then you will be planning the entire infrastructure like the bus bar, the transformers, everything will be planned as for that. Also, you will be going for the connected contract demand with the grid according to that. You have to first you have to plan like what are the equipments that will be in load condition at which time. Then you have to consider the planning of maximum demand. So for an example, if you can consider in a factory, it has a machinery of 50 kilowatt load, lighting system of 20 kilowatt load, and HVAC system of 30 kilowatt. Together, the connected load will be 100 kilowatt. But at all the time, all these equipments won't be in running condition. Either it may like they may operate at that 50 kilowatt plus 20 kilowatt, or 20 kilowatt plus 30 kilowatt, or 50 to 30. So the maximum demand that can reach at the side will be if you operate the machinery and HVAC will be 80. So it helps in determining the contract demand. Let me take an example of a industrial energy bill to explain the demand calculation, how it has been done. If you see here, the quota or sanctioned demand is 350 kVA. That is an agreement between the user and the grid. They are agreed to purchase 350 kVA sanction demand, like contract demand from the grid during the particular period of 1 month. During the operation of the industry, we have recorded the demand of like the trivector meter installed by the grid. We have installed the recorded demand of 156.40 kVA. This is far lesser than the contract demand that they have made agreement with the grid. But there is a class on the billing demand that 90% of the sanctioned demand or recorded demand, whichever is higher, has to be paid. If you see the condition here, the recorded demand is not even close to the 90% of the sanctioned demand. It is 156, less than 50%. So we have to like now as per this class, then you have to pay the amount for 90% of the sanctioned demand. The 90% of the sanctioned demand of 350 will be 315. So the maximum demand rate, like the 562 per kVA was the before rate. Now it has been revised to 582. This is a old bill. That's why I'm mentioning here. So for every month, even if you recorded demand was less than the sanction load, you have to pay this 90% of the contract demand. As 562 rupees per kVA, you have to pay this amount. Then coming to this is about the demand charges. Coming to the next category, energy utilization cost. In this, you can find 2 to 3 categories. Industrial consumption, the rate is 8.7 rupees per unit. The unit mentioned here is 70,520. That is the overall kilowatt hour consumed. Then peak hour consumption, 2.18 rupees per unit. This is over the amount of 8.7 per unit. Like over that amount, you have to pay it as like a kind of penalty you have to pay for the peak hour consumption. Then night hour consumption, yeah, like you will be getting 5% rebate from the industrial consumption rate. That 8.7%, you will be getting 0.5 5% rebate on the unit that you are consuming at the night hour consumption. These are different slots provided by the grid for the users. Like this is a sample of bill that how the industrial bills has been generated by the grid. I just want to have a quick question here also. Why energy cost varies according to the peak and non-peak hours in the electricity bill? I have mentioned here 2 to 3 categories of cost per unit of energy consumed is here. Why this changes is there in the bill? Like, can anyone say this in a chat box?
Chat is enabled now. Participants, you can type your answers.
So the response I'm getting is to meet out demand and supply due to loads connected during peak hour.
Okay, I'm getting responses. Demand of electricity production.
You can directly paste the messages, participants. It is not necessary to me. Put it to everyone so that the speaker is also able to see.
Yeah, like don't give it for a direct message. Give it to everyone so that everyone will see the
Yeah, that
answer.
is what I was saying. Do it to everyone. A lot of messages are coming to me directly. It says it's low as vice versa, load balance to maintain the grid stability. Peak demand is met with costly generation units such as gas PP or diesel PP.
Okay. Okay, thanks for the reply. Let's continue with our slide.
Thank you all.
Thank you. Thank you for the responses. There are few like reasons for why this different slots of price has been kept in the electricity bill to manage the demand fluctuation. Like if you say the customer that during the evening time everyone the load consumption will be higher due to the people will be spending more time in their house, the lighting load will be there, AC loads will be there, television loads will be there, they won't accept. Like then you have to give them some incentivize that if you consume at the peak hours, then you have to pay the excess amount. If you go for the night hour consumption, then you can get rebate. So accordingly the demand fluctuations will be managed. Like suddenly you can't give a spike to the grid. The grid generation will be in a nominal side, so you don't want to stress the grid. So that's why for managing the demand fluctuations we give this. Also to encourage the load balancing, the industry people has to plan in such a way that all the connected loads should not be operated at the same time. They have to plan according to their requirement, like followed by the process. If you consider an example like continuous process, one followed by the other, or it has a different category wise of processes, then they have to give priorities, and then they have to manage the load so that the contract demand will be lesser, the grid won't be in stress, for reducing the operational cost. Sorry, operational cost means like if you are going for more production at the non-peak hours or in the night hours, eventually you will be paying less for the units that you are consuming. In such way, you will be reducing the operational cost. This will be directly affecting on the specific energy cost for production of any product. This will also improve the margin of the product also to maintain the grid stability. All these factors will be indirectly related to the maintenance of grid stability. Then the relation between connected load and the contract demand. Contract demand often depends on the connected load only, but they are not the same thing. To be precise, we can say they are not necessarily equal. They can be equal also, but the connected load will be always more far higher than the contract demand. That's why we tell them to optimize the contract demand by setting the priorities in such a way that at what time which load will be in operation condition. This requires strategic planning. That's how we can relate the contract demand and the connected load. For example, if you consider a chiller system, there will be it is an HVAC system. It will be having pumps for the transfer of cooling load. Like the chilled water will be transferred from one place to another. For an example, you just consider it as a pump. There are one running pump, and for the running pump, there will be two standby pumps. The running pump will be all these three pumps are having the rated power capacity of 30 kilowatt. The running pump is one, and the standby pump is two. Together, if we sum all the rated capacities of all these pumps, including running power, so running pump and standby pump, we will be getting overall connected load of 90 kilowatt. Among which these standby pumps are meant only for the operation once the running pump is under fault condition, or if it like any dispute comes in the running pumps. So here the connected load is 90 kilowatt, but we will be using only the 30 kilowatt. So this clearly explains that the contract demand and connected load is like different, and but they are related. For the condition that running pump is operating at 30 kilowatt, all the time it won't be at 100% loading also. So the maximum demand even it can come under 30 kilowatt also. So we have to plan accordingly that by considering the connecting load in our mind, that the contract demand has to be placed in a like a correct point of amount. Then coming to the demand side management. Demand side management is the one of the major activity by the Bureau of Energy Efficiency also. They just want to um, properly manage the demand from the user end. If you can it directly relates to the reducing the peak demand and also for improving the efficiency. This will directly affect the grid, which is generating energy for the user. Its goal is to major goal is for the energy management, demand side management is to manage the energy demand rather than increasing the power generation. If we could able to manage the energy demand at a proper point of view, then the power generation infrastructure does not require to be increased. The key objective is to reduce the peak demand, that the peak demand at a sudden surge at a point of time has to be reduced. Improve the energy efficiency. If you improve the energy efficiency, then it will be reducing the indirectly it will be reducing the peak demand only. If you reduce the peak demand, the contract demand will be reduced and the energy utilization cost will be reduced. So lower energy cost, supporting the grid reliability also. If you maintain the same amount of load throughout the day for the grid, then it will be easy for the grid to handle the situation. Rather than giving lesser load at the mornings and sudden surge at the evenings, then grid will be getting it won't be reliable. There may be a chances of getting stress developed in the grid. And also if you go for the lower demand, the utilities that are been supporting the grid at the generation side will be the same. So the utilities cost will be same even if you generate the lower amount of demand also. It directly it also affects the environmental benefits. So the coal based power plants plays the major role in power generation. If you could reduce the peak demand, then it will be reducing the generation also. Then the CO2 emissions will also be reduced. The method that is followed in the DSM is energy efficiency program, then demand response, then time of day pricing, the slots that we have discussed in the bills, then load shifting, renewable energy integration. If you come to view this diagram, you can see the strategic load growth, strategic conservation. Then strategic load growth is just to improve the load at the non-peak hours. Then strategic conversion is reducing the load at the peak hours. Then flexible load shape, like rather than having indefinite rational load shapes, we can plan a load accordingly. Then we can manage our demand. Then peak load reduction, then valley filling, then load shifting. These are the major types of practices followed for demand side management. Maximum demand control. For managing the demand, for managing this demand side management, maximum demand indicators, maximum demand controls that can be used, because once if we are operating or if we are producing a product in the industry, we will be going with the flow. We won't be checking continuously that whether this demand is getting hit on our contract demand or not, like whether it is getting extended about the contract demand that we have purchased. Like even if it goes slightly beyond the contract demand, then we have to pay the penalty charges. So we can use the maximum demand controllers, where there will be a set point set at the load end, that if we going clear like close to the exceeding the contract demand, then it will be automatically turning off or optimizing the loads, and it will be turning off the load, so that the condition won't be going beyond the contract demand. Then the benefits of this maximum demand control is cost savings, then energy savings, better resource allocation can be done, sustainability, like it will be related to the reduction in emission, and also overloading will be avoided at the grid end and also at the user end also. If you could see this graph, like don't tower your power and level out your load, you can understand this. If you turn on all the utensils, equipments in your home at the same point of time at the 5 p.m., it has been given that we have a 9 kilowatt of demand. Like even usually we'll be having 5 kilowatt of demand. If we turn on all these equipments at 5 p.m., then the demand exceeds 10 kilowatt also. But if we plan, then if we plan and if we start utilizing the load, like we can use the washing machines, or we can use the heaters, or we can use our other electrical based equipments according to the time. If we scatter it and utilize it throughout day, then we can manage the demand within 4 kilowatt, less than our contract demand that we got from the grid. This is one kind of a simple way of explaining this demand control. Yeah, why is contract demand crucial for effective power generation? Can go with this. It is majorly helping in planning the supply. For the grid point of view, I'm saying it if all the consumers are planning according to the contract demand, then the supply can be managed from the grid side. How much energy has to be generated and how effectively it has to be given. Grid stability. Grid stability also it plays a major role. Then cost management. If you could generate less amount of if you could give the contract demand in a proper way, then the cost management can also be the utilization of the grid will be underutilization or overutilization won't be there. So the proper cost management can also be done. If you could control your demand within the contract demand, then you can also avoid the penalty from the penalty will be from the operational risk for both the generation side and also for the consumer end. Then coming to the power factor. Power factor is I have given a simple representation is a cup of cappuccino here. Like usually we'll be paying the amount for the entire cup that has been explained represented here, but it will be considering consisting 75% of coffee and 25% of the foam. But we have to pay for both foam and the coffee, in which the coffee is the only thing a real product that we will be giving the amount for. It also comes with some reactive power like the foam. Together with this, we will be paying the money and it will be considered as the power. As an definition point of view, we can say how effectively the electrical power is used by the system or load at the user end. It can be in terms of formula, we can say it as ratio of real power and to the apparent power. We have to maintain the power factor to the unity for getting the exact amount of power that we have utilized it as a real power only. But in a practical condition, there will be a lot of problems in maintaining the power factor to 1. We will be using lot of inductive loads. We have to give additional devices to cap up with the inductive loads to bring back the power factor to unity. Then there are two categories we can define the power factor: lagging power factor and leading power factor. Lagging power factor usually comes with the inductive loads, the motors and transformers, in which the current will be lagging behind the voltage. That is considered as the low power factor. Then leading power factor. Leading power factor is for the captive, like capacitive loads. It is for the capacitive banks. That will be helpful in assisting in bringing back the leading power factor to the unity power factor. This directly related to the efficiency of the system, how effectively we are using it. If we use the exact amount of energy that we are consuming it to the uh, utmost for getting the output, then the energy cost will also be reduced. If you maintain the poor and poor power factor, then you have to pay more for the contract demand. Your demand will be exceeding, then you will be paying more money for the grid side. Like you have to get a huge contract demand and you have to pay them. It also relates to the energy loss, the other term of efficiency. If you are low efficient in utilizing the energy that you have bought, then you are losing the energy. It as a loss. Low power factor mostly due to inductive loads. The major effects will be if it is lagging behind, then current will be increased. If the current increases, then I square R loss will increase. If the current increases, then you have to like the wires that already have been connected there will be getting overheated, and this will increase the demand charges. Then it will be affecting the equipment side also. Voltage level will be getting reduced at the further end of the loads connected. Coming to the APFC, the way that we will be performing the performance assessment of capacitor banks will be, we will be measuring the individual phase current and kVAR. The individual phases has been measured just to make sure that all the three phases are working in a proper way. Then by this phase current and kVAR, comparing it with the rated capacity of the capacitor banks, we can conclude that the derated value of the capacitor. Then for the 1 kVAR capacitor bank, it will be consuming almost 1.3 amps. It's a kind of thumb rule where we'll be checking during the measurement of the performance of capacitor banks. Then coming to the electrical line diagram, most of you guys will be well versed in this. There is a line diagram. This you have to be aware while going to the industry while checking any electrical utilities. This will be helpful for us in tracing out the equipments or the lines, that how the electrical energy distribution system has been made. Then coming to the transformer. A transformer is a device used to either step down or step up the voltage just to utilize it as per the requirement at the user energy, user end. It has to transfer energy from like the HT to LT, then we will be utilizing it in our end. It works on the principle of electromagnetic induction. Then we will be having turns at the primary end and the secondary end. Based on our requirement, we will be either stepping down or stepping up, and we will be using the energy there. The major components and types, the major components include the core, then primary coil, secondary coil, and insulation. These are the major components of the transformer. Coming to the type of transformer, there are two major categories that we will be prioritizing: power transformer and distribution transformers. Distribution transformers are used for stepping down from higher voltage to lower voltage. These are mostly at the industrial sites and residential sites, where we will be getting the energy transferred from the grid or substation, and then directly we will be utilizing it for the user end. This purpose will be served with the help of distribution transformer. The voltage levels will be typically up to 37 kV. Then capacities ranges from 25 kVA to 5000 kVA. These are operated to work under the varying load conditions, because in the industries the loads won't be similar at all point of time. The fluctuating loads will be there. Even for the fluctuating loads or lower loads also, these transformers has been designed to perform in a better way. This efficiency point of view, you can say that at lower loads only the efficiency of these distribution transformers will be higher. It will be installed just related to nearest to the end user location, so that there won't be any further transmission loss after converting it on the distribution transformer. Coming to the power transformer, it is used to either step up or step down voltages in the transmission network, power plant to the distribution system. Then the voltage operated will be 33 kV to 400 kV. Its capacity ranges from 5 MVA to several hundred MVA as per the requirements. Operations. Coming to the power transformers, it is not as a distribution transformer. They are meant to operate effectively at their full capacity. They will be operating at a maximum capacity at a constant load at higher load conditions. These are installed near the substations or power generation plants, where there will be a requirement for stepping up or stepping down of voltage levels. Coming to the transformer performance parameters, like the factors that will be affecting the transformer's performance will be transformer losses. Coming to the losses, we can categorize it into core loss and copper loss. Core loss further as hysteresis loss and eddy current loss. Core loss is not related, like it is independent of the loading that we are providing to the transformer. The copper loss is related to the loading that we are providing to the transformer. Presently, the transformers are manufactured with the losses less than 1%. Then higher harmonics has the effect. Loading of like either overloading or underloading also affect the performance of transformer. Insulation, poor oil quality, then silica gel condition. If the silica gel condition is very poor, then it can't able to absorb the moisture in the transformer, then it will lead to the tripping of transformer also. Then poor power factor. It will be directly affecting the demand that is loading of the transformer. If the loading is getting higher and higher, then distribution transformer's efficiency will be reduced. I have described here, presented here a nameplate detail of a transformer, in which you can see in the right corner that energy efficiency level is 2 and maximum total losses at 50% rated load, and maximum total losses 100% rated load has been given in the nameplate itself, in which they have given the load loss and no load loss, like core loss and the copper loss together in this nameplate. We have a formula that the total loss is equal to load loss plus percentage of load square to the product of your load loss. With this, we will be getting the total loss of the transformer. The best recommended loading percentage of the transformer will be found using the formula no load loss in watt divided by full load loss in watt, the square root of this ratio to the product of 100. You will be getting the term in percentage. For the nameplate of the transformer given here, I have calculated the load loss and no load loss and presented the best recommended loading percentage here. Let us have a look. At the 50% of load, you have to frame the equation as per the formula that is described above, and you have to take the values as the 50% has to be total loss is 2790, and for 100% loading you have to take 7790. At the PT, these values will be replacing. Then if you solve both these equations, then you will be getting no load losses 1153 watts and load losses 6547. If you go for the best efficiency loading percentage, as you got the load loss and no load loss, you will be applying it in the formula and you will be getting the loading best recommended loading percentage. It is 41.96%. If you convert it in terms of the rating of the transformer is rated at 1000 kVA. If you product this, then you will be getting the best recommended loading capacity as 419.65 kVA. If you operate the transformer at this capacity, then you will be getting better efficiency for this transformer. Practically, it is not possible that all the time you will be operating at the same loading point. But if you have to you have to design accordingly that most of your load patterns will be lying within this range of best recommended loading percentage. This is a theoretical way of calculating this. For at the site for real-time transformer loss calculation, what we will be doing like practicing at the end is we can't able to figure out the core loss, like the copper loss and core loss together. So we have to we can't calculate it individually, because at the industries it is not possible for them to shut down the production and giving us time for finding out the core loss. So what we will be doing is we will be connecting two power analyzers, one at the input of the transformer and one at the output of the transformer with the same accuracy. Then we will be logging the energy consumption rate of the transformer. We have to take the difference of this and we have to divide it with the input energy so that we can find out the real-time transformer losses. If they insist us in finding out the core loss and copper loss separately, then at the time when the shutdown happens, they have to they have to shut down all the loads and the transformer has to be free from loading. Then we have to follow the same procedure. The energy consumed by the transformer will be considered as the load loss, and at the time of normal loading condition, then again we have to do the same procedure. Then if we if we get the difference of the normal condition and without zero load condition, then we will be getting core loss and copper loss in a separate way. But it is not practically possible at all the time. Then coming to the power quality analysis. Power quality analysis, this has been done to check the healthiness of the system that is present in our industry. Like how effectively we are handling the energy that has been procured from the grid. How effectively we are utilizing it. For checking that, we will be doing the power quality analysis. In this, we will be checking the parameters such as voltage variations, current imbalances, the harmonics generated at the our system, then power factors, flickering, spikes, then imbalances. All these categories will be done under the IEEE standard of 519. This is the standard used for doing this power quality analysis. Coming to the harmonics, if the harmonics will be developed at all the points where we will be disturbing the fundamental frequency of the system. If you disturb the fundamental frequency, then harmonics will be developed. The harmonics will be kind of a distraction for the energy that we are supplying to the system. It won't affect only the system that is generating the harmonics. It will be affecting the entire system that is in a closed loop with the system which is generating harmonics. The overall impact of voltage and current harmonic distortion will be called as total harmonic distortion or total demand distortion. It is depending upon the condition of loading that at which point of time we are measuring this. There will be a standard for 100% loading, but all the time industries, while we are doing the assessment, industries won't be meeting the 100% loading of the site. So at that 50% loading or the 60% loading, we will be doing this analysis and we will be mentioning it as total harmonic distortion. For at the time of 100% loading, if we measure if we do the same thing, then it will be considered as total demand distortion. The linear voltage applied to the non-linear voltages will be leading to the harmonic generation. The non-linear loads such as diodes, SCR, transistors, IGBTs, The equipment that are familiar in generating harmonics are variable frequency drives, UPS machines, ballads, arc furnaces, welding sets, etc. Then coming to the motors and starters. Motors are devices that will be converting electrical energy into mechanical energy, which will be helping us in several ways in doing our work at the industries. These starters are used for initiating the operation of the motors. There are the starters are usually used to safely start the equipment and until reaching the desired speed of the motors. So initially the surge current will be there, higher current consumption will be there at the motors to to prevent the problems of that starting conditions. These starters will be used. The direct online starters are there. Then star delta, auto transformer, soft starters, variable frequency drives are there. If you could see the graphs that is shown here, soft starters are more convenient for starting the motor. Variable frequency drives, rather than starters, it can be used at the point where there will be various fluctuation of loading for the operation. There, the variable frequency drives pays the better option. Additionally, it will be playing the role of starter also. Also, it will be helping us in terms of energy efficiency practice, where there is a huge amount of load variation in the application. And then the categories like types of induction motors, squirrel cage induction motors, slip ring induction motors. Most of us will be aware of about these motors. Based on the location requirement, these induction motors will be selected for the applications at the industrial side. Then synchronous motors, they have the higher efficiency or speed control. Based on the applications, for the precise control operations, the criteria of motors has been selected in the industries. Major uses of motor in any industry is just for driving the machinery. That is one of the major uses of the motors for operating the conveyors, pumps, compressors, etc. And also for automizing the process to get rid of the manpower or to get rid of to improve the efficiency. Nowadays they have started automizing the process. These motors plays a very major role in automizing the process also. Then for material handling, for handling of equipments through lift trucks or conveyors also as a point of material handling. Then in when the motors are coupled with the fans or EHU, then they have been used for the ventilation purpose also. For water management, they have been coupled with the pumps to deliver to transfer fluids from one point to the other point. Then in point of manufacturing, they have been connected with the mills, lathes and other processing tools wherever necessary, it is necessary. And then in terms of motor, there is a energy efficiency rating. International energy efficiency rating has been developed and followed by the motor manufacturers. There are 5 major categories: IE1 to IE5. It the efficiency rating of the IE1, the standard efficiency will vary from 81 to 89%. Eventually, the high efficiency motors, premium efficiency motors, super premium efficiency. Slowly, the motors are getting replaced in the industries from IE1 or IE2 to IE3 or IE4 based on their requirements. Even Bureau of Energy Efficiency has started a program in collaboration with the EESL for replacing the low efficient motors with the energy efficient motors in the form of ESCO mode, in which they will be replacing the motors and they will be proposing the real-time savings. The pre-study before replacement of motor will be carried out and the power consumption patterns will be noted. Then after replacement of the energy efficiency motors, then the same procedure is done. The difference in amount will be considered it as a energy savings. These energy savings will be shared to the like the ESCO company which has been implemented this changeover of the motor. Then or else it will be in a sharing basis. The energy savings that has been achieved at the user end will be shared either as 50-50 or 60-70. Both the ESCO company will be getting benefited, and also without the investment, the user end is also getting benefited with this. Here you can see the graph representing the efficiency percentage of IE1 to IE4 for a 4-pole motor. Then coming to the benefits of higher efficiency motors, if more and more efficient the motor is, the energy consumption will be lower, so energy cost will be getting lower. If the energy consumption is lower, then environmental impact will be reduced. If we are doing the task in an effective way, then our performance will be improved. In energy assessment point of view, motor performance analysis is done in 3 ways. Like as I said, for the transformer, the losses in this motor will be like they can't be found at the site. That is not practically possible, but it is possible at the laboratories. Even in engineering, in some of the laboratories, you could have performed the experiments on finding the performance of motors also. So here we will be checking for the loading of motors. Then we will be checking for the surface temperature of motors with the thermography. Then for slippage, we will be checking to check the efficiency of the transmission. How effectively the energy generated, like the mechanical energy generated by the motor is transferred to the utilization, like to the process. In the loading of motor, we will be getting an idea like whether the motor is getting underutilized or overloaded. Based on that, we can give suggestions for the improvement of the energy efficiency. Then the thermography will most probably it will reveal the higher winding temperatures. Then slippage will be revealing the transmission loss. The reason for poor performance of motors will be mostly wrong selection, like the higher capacity selection. We will be selecting higher capacity, or going for lower capacity selection and overloading the motor. Then voltage unbalancing, a lagging power factor. This will cause the I square R loss to increase. Then loading pattern. If the loading pattern is huge, then we have to assist it with the help of VFD drive so that the operation will be effective. And then multiple times rewinding the motors. If we keep on rewinding the motors, then the procedure that has been followed for winding the motor at the time of production won't be repeated during the rewinded condition. The efficiency of rewinded motors will be getting drastically reduced. If we keep on doing it for multiple times, then the original efficiency will be drastically reduced and the performance of motor won't be good. Then belt slippage is also a major reason. Poor bearing control. If your bearing is not proper, then it will generate heat and there will be the jamming of rotor section will be there. Then huge amount of energy will be consumed for doing that work. If you consider the percentage of the graph here, you could see the slip, current, power factor, and efficiency in relation to the rating of load. If the motor is loaded less than 40%, like, or else if you could say the motor is underutilized less than 40%, then you can go for the automatic star delta star converter, which will be this is one of the suggestions that we will be recommending at the industrial site. If we could notice the loading percentage of motor as less than 40%, but if they have wrongly selected the higher capacity motor. If we there will be a load sensor placed here. If the load will be getting less than 40%, then the star mode will be getting activated. If it goes beyond the 40%, then delta mode will be activated. In the right side graph, you could see in the star delta connection, the power factor is getting affected with respect to the loading pattern. You could see that in the graph. By this energy conservation method, we will be getting an energy savings of around 10 percentage. Like yeah, as it is mentioned here, in a 18.5 kilowatt motor, from delta mode to star mode, after converting it, we have got a energy savings of around 11.3 percentage. Slip and types of belt. Uh, slip. The slip can be considered in two point of view, like in motors point of view and in belt drives point of view. In motors point of view, the rated load, the rated speed to the actual speed at the 100% loading. Finding the motor slip is also bit difficult at the site, because we can't make sure that all the motors are 100% loaded at the time of measuring the slip. So that study won't be viable at the site. In terms of belt drives, we will be measuring the slip by measuring the RPM of both the pulleys, driver pulley and driven pulley. Then we will be substituting in the standard formula, and then we will be getting the slip percentage. Usually the slip percentage has to be less than 2%. Uh, Coming to the belt types, there are flat belts, V belts, cocked V belts. Among these, cocked V belts are more effective in transmitting the energy. Monitoring the slip will be help us in reducing the losses through transmission, and also it ensures the effective power transmission. Performance improvement on motors, like for getting better efficiency on the motors, we have to do the proper sizing of the motor. And then energy efficiency motors has to be installed, like you go for the IE4 motors or IE3 motors. If loading percentage is more like lower than the 40%, then you can opt for the like a star del star converter. Then all the three phases has to be balanced. The supply has to be balanced. Then power factor has to be maintained in the circuit, so that there won't be any losses. Then winding temperature and bearing temperature should be properly maintained. You can consider, like it can be goes up to 10 to 15 degrees beyond the ambient temperature. If it goes more than that, then we have to check the mechanical components, or like the rotating components of the motor, and we have to give attention for that. Built slippage should be less than 2%. If it goes beyond that, we have to check the belt tension, and then we have to replace the belt also. Coming to the power clamp meter, for assessing the motor capacitor banks, these power clamp meters plays a major role. With the help of this power clamp meter, we will be without disturbing the working condition of the equipments, we will be measuring the current, voltage, power, then energy. This with the help of these measurements, we can directly compare it with the rated power or current voltage of the motor, and we can come to a conclusion that whether is there any issue with the operating conditions of the motors or any devices. Then we can start doing the troubleshooting. This is also helpful in verifying the changes, like after implementation and before implementation. These data will help us in finding out the energy savings. This works on the principle of magnetic induction and Hall effect, where we will be measuring the power parameters with this power clamp meter. Tachometer. This tachometer is used for measuring the RPM of the driver pulley and driven pulley for measuring the slip. This has both contact and non-contact type, which is used for measuring the motor speed, so that we can directly get the slip percentage of the motors, and we can take corrective actions if the slip is getting to the higher side. This works on the principle of physical contact with the contact mode, and then for the non-contact mode, it goes with the optical or magnetic means. There it will be like generating the, like sensing the pulses. We have to stick a reflective coating sticker at the driver pulley and driven pulley, then we will be measuring this non-contact type speed measurement. Then the device will be processing it and giving the answer at the display in point of RPM, so that we can directly utilize it for the calculation purpose. Then coming to the lighting, lighting plays a major role in all the domestic commercial buildings and industries also. It goes up to 10 to 20% of the overall electric load. So from the starting, it has started from the candles, then incandescent bulbs, then fluorescent bulbs, halogen bulbs, CFLs, LEDs. Then coming to the smart lighting, where we could control the illuminance of the light also. These are the evolution of lights, where we have evolved from lower efficiency to the higher efficiencies. Presently, these lights are most of the lights are going for the LEDs, so that they are energy efficient in nature rather than going for the conventional fluorescent lamp. Lux meter. This lux meter is used for measuring the illuminance generated by the light. We have a set of we'll be having a set of standards as per building codes, and we'll be having that for this conference room, for the lecture rooms, like, or for the hotels, what has to be the illuminance range. We'll be measuring it with the lux. If it is greater, then we'll be optimizing the lights. If it is lesser than the level, then we'll be suggesting them to improve the lightings. This will be the working principle is based on the photoelectric sensor. It will be detecting the light, and it will be converting it into the electric signal. Then the corresponding lux will be given displayed in the lux meter. In the point of on the point of lighting, Bureau of Energy Efficiency has taken several initiatives continuously for improving the energy efficiency on the side of lighting. At the 2015 Street Light National Program has been introduced, in which across India, EESL as a partner for replacing the conventional light into LED lights, government has taken this initiative and replaced almost all the street lights into conventional street lights into LED lights. Now you could witness most of the street lights are of LEDs. This also have a relation to the energy savings of 8.2 billion kilowatt hours per year. Also, it has indirect effect on reducing the peak demand of 1374 megawatts. Then coming to the environmental point of view, GHG emission reduction of 5.68 million tons of carbon dioxide per year was done. Then coming to the Gram Ujala, this is for replacing. This is also a similar program initiated by the government for replacing the old type of bulbs with the energy efficient LED bulbs, which is of 88% less electricity. This was also resulted in energy savings of 467 million kilowatt hours per annum. Then coming Ujala scheme was introduced, where government has decided to give LEDs to the domestic individuals at a affordable rate, or at a subsidized rate. The original cost is around 300 to 350 per bulb, but it has been given in a subsidized rate of for the consumers, just to promote the energy efficiency for the lighting activities. Then coming to the ceiling fans. Fans are more economical option for creating comfortness to the human. Presently, we are all utilizing these air conditioners. Previously, most of us will be are using the ceiling fans for the creating comfortness for the human. This is used for improving the air circulation, and also energy efficient, not energy efficient point of view. Rather than going for air conditioners at all the time, you can switch for the ceiling fans, where you could manage with the comfortness. Coming to the energy efficient option in the ceiling fans, the conventional ceiling fans are presently replaced with the BLDC, brushless DC fans. The energy consumption of the conventional fans is around 70 to 90 watts. Presently, the BLDC fans are consuming 25 to 35 kilowatts. Almost 50% of energy savings can be attained in this. Due to lower number of mechanical parts, the shorter lifespan of the conventional ceiling fan is there. Due to lower number of mechanical parts, the BLDC fan is having a huge lifespan. Then speed control in this conventional, it will be done by regulator. There it is controlled electronically, even with the help of remotes. Now we are controlling the speed of the fan. Then coming to the cost, the conventional fans are lower cost, but the if you consider the life cycle energy utilization cost of the conventional ceiling fan, then you could there will be definitely savings on investing at the BLDC fan. So you could better invest initial higher amount for the BLDC fan. Throughout the lifetime, it will be consuming very less amount. Coming to the maintenance point of view, BLDC fan is of lower maintenance. Yeah, that's all. Thank you.
Thank you, Mr. Sai Ramana.
Yes, ma'am. Thank you.
Is now Mr. Jayaprakash having something to present?
No, ma'am. We are done with it.
So this is a session for today, right?
Yes, ma'am. Yes, yes.
Yeah. So thank you so much for patiently taking us through through the session and explaining to us on the electrical energy assessment for the electrical utilities. Thank you for that. Participants, if you have any questions, I'm going to keep the chat box enabled now. You can use the chat box, Zoom chat box, and type your questions. Meanwhile, Robin, can I request you to please place the Slido link? Yeah, so enough, only one time you paste, please. So the Slido link has been pasted in the chat box. Click on the link if you have not registered. Earlier, if you have registered, so leave it in the beginning of the session. But if you haven't, kindly take a minute and click on the link and register. Questions can be asked, as I mentioned earlier, you can ask your questions either by sending us a mail to askpalspmo@gmail.com. We have been monitoring that the mail account. If there are any questions, we'll get that asked. You can also type it in the chat box, or you can raise your hand and ask your questions. So we will now be starting the quiz. Kindly take some time to register if you have not registered already. Give me a second. Let me.
Mr. Sai Ramana, you can stop share your screen.
Yes, sir. Yes, sir. Is it fine now?
Yeah, that's fine. Thank you.
Okay.
Okay, I'm going to share my screen now. So consistently, we have been having 380 odd participants participating today. Thank you for that. We hope that you'll show the same commitment to taking your quiz also. So quickly log in. The good practice, again, I'm reiterating, is to register with your college short name. Those of you who attended the first session did notice that there is a leaderboard that we show. So when your name comes along with your college short name, it adds a little bit more effect. And that's your true identity. So please add your name with the college short name. We have 40 odd partner colleges of PALS. And you can type your questions in the chat box. We'll get those questions answered from the speaker. Okay, 213. So let me, Robin, you have something to say?
Yeah, ma'am. Question has come, so.
No need. Please keep it. We will finish this quiz. Keep it. So we will be starting the question now. The session is not, the quiz is not responsive on the Zoom. So as you click the link, it will take you to the browser. Stay on the browser. And as in the previous session, it is a timed quiz. Each question will be shown with 4 different options. You'll have to click the correct option. And that is all within 15-20 seconds of time frame. So the first question here for you. I hope you are able to see the question. The percentage of loss of thermal plant efficiency and high voltage transmission losses. And there are 4 options. You have to click on whichever option. Zoom screen will not be responsive. You'll have to do this on your browser. I request all of you to take part in the quiz. Srinita, the quiz link has been published all along. Robin, can you please help Srinita of VCW? The right answer for this first question is option D. And 29% of you have got it right. All these questions are from the session today. So if you have listened keenly, you will be able to answer. Moving on to the second question. Okay, here again, there is a mixed response. Probably Sai Ramana or Jayaprakash, you should, at the end of the quiz, you should give a little explanation on why this mixed response is coming. Some clarity may help them. The right answer for this is option C, soft starter. Third question. Again, a split response across. And the right answer, IE, what does it stand for? It is international efficiency. So avoid doing the guesswork. All these were discussed in the session again. Fourth question. Option B, correct. 51% have got this is a good response. Moving on to the fifth. Probably it's a generic question which you must have studied in your syllabus as well. You should get a good response for this. Okay. And C is a right answer. Good. Now, if you can leave your screen as it is and come to the Zoom screen. Shift your focus to the Zoom screen. Tyagarajar College, Vishnu Darshini seems to be have got all the 5 questions right in 1 minute, 1 minute duration, followed by Divya Purni from Rajalakshmi Engineering College, Selva, we don't know from which college, Pavitra, not from which college, and followed by Deekshit from REC, again, Rajalakshmi Engineering. All of them have got 5 on 5. But what makes Vishnu Darshini at the top is because she has answered the question fast. So now we will continue with the quiz. The leaderboard position may change. So be fast and be correct in your answer. Please go back to your quiz. The 6th question here for you. Okay, and tachometer is the right answer. Good. Moving on to the 7th. Option A is the right answer. 8th question. Option B is the right answer. 9th. Any generic questions from your syllabus? Silicon steel, option A is the right answer. The last question for this session. I'm excited to see the leaderboard. Be quick in your answer. Again, here the answer response is split. Option C, high pressure sodium, HPS lamps is the right answer. So now come back to the Zoom screen and let's see the leaderboard. Selva has managed to go up. Prakash Raj has also managed to go up. Tyagarajar College, Jamesh is in the leaderboard. Pavitra still managed to be there, and Bhargav Macha. We don't know from which college, but then yes. So congratulations to all of you who have participated and who managed to be on the leaderboard. Hope you have had some good learning. I will stop the screen. We will now open up the session for Q&A. And I would request all of you to use this opportunity, ask as many questions as possible. It's not like every day that we have industry partners coming in and, answering your questions. So make use of this opportunity. We still have some time left with us. You can raise your hand, send a mail to askpalspmo@gmail.com or type your questions on the chat box. Chat box is enabled.
Ma'am, one question from Mahesh BVRIT. Please suggest the latest low energy consumption devices.
Mr. Sai Ramana
Sai
or
Ramana.
Jay Prakash? Yeah.
Yes, ma'am. Like the question is very broad, so that like in which area they are asking about the energy efficient equipment.
So whoever has asked the question, can you please be a little bit more specific? Okay, there are a few more questions, Mr. Sai Ramana. Just give me a second.
Yes, ma'am.
Okay, you're able to see my screen. Are you able to see my screen?
Yes, ma'am. Yeah.
Yeah, the first question is, what are the types of industries facing the leading power factor issue?
Yeah. The leading power factor industries, as we came across, I have witnessed the leading power factor issue in the textile industry, where they have installed the amount of capacitor banks as higher side, like rather than the required amount, they have increased the capacity of the capacitors, and also the sensing problem was the issue. Like uh, usually we'll be taking feedback from the single phase for managing the automatic power factor controller, but due to the unbalances in like various phases, three phases, we can't able to match the power factor with respect to the feedback from the single circuit. If we could go for the three phase sensing, then we can properly control the power factor issue. As for site visit, like I have witnessed the leading power factor issue in the textile industry, where they have installed the capacitor banks to the more amount of kVAR capacity than the required. So lux meter is a device that is used to measure the illuminance level of the lighting. It's a handy device where we'll be carrying it with us. Like the study includes, like we have to keep it at our waist level from the ground. Then we have to measure the light illuminance level. Then we have to compare it with the chart of the standard that has been given by the building codes or ECBC. Any standard codes we can compare, and we can give suggestion for the amount of light, whether it is enough for this room or like it has to be improved. That's how it is. How to become energy assessment engineer? Energy assessment engineer, you can follow our page, LinkedIn page, so that you will be getting an opportunity to join as an energy assessment engineer. Kaisam, IIT Madras. You can go in LinkedIn and you can search so that you
Sai
can
Ramana or
find
somebody,
it.
Jay Prakash, can you paste this LinkedIn page on in the chat box if it's okay?
Yeah.
One of you can
Yeah,
do that.
yeah, okay, ma'am. I will.
Yeah.
I will.
Sai, I just request you to place the QR code so that people can just scan it and maybe they
Ma'am,
can follow our page as well.
can I use 1 or 2 minutes for the placing the QR code, ma'am? Can you allow me to share the screen?
Yeah, I'll stop share.
Okay.
So Hafisa Nasreen from MAMSET, you asked this question on energy assessment engineer. Follow the energy consortium team. Save this QR code. So to all those of you, we repeat again, the QR code here is the LinkedIn page of the Energy Consortium team. Any questions, any further information on what are the career prospects, how do you become an energy assessment engineer and all that, you will be able to know more if you follow on this particular link. Mani Royal. Can you want to ask a question? You can unmute. I have allowed you to unmute. You can unmute and ask your question. Okay, there's one more question on how to use efficiently the home electrical appliances. A very generic, again, a broad level question.
Yeah, at a base level, I could say like utilize the electrical devices as per your requirement. Don't exploit the resource like energy. Like if you are going out of a room, like please do turn off the fans and lights. Don't keep your TVs in a sleep mode. These are basic things that you can like turn off the lights whenever it is not required. Use the daylighting. Then keep your AC set temperatures above 24 degrees Celsius. This could help you a lot in saving energy in terms of domestic.
So Logachandran from Tagore Engineering College, I hope that answered your question. Any further questions? Anybody participants? Any other questions that you have? There are no questions on the email. We are monitoring it. Yeah, the LinkedIn, the link for the LinkedIn page is also there on the chat box. Okay, I think if we have any follow-on questions for session 1 and session 2, we are open to answering your questions. We still have the 3 more sessions. The next session is on the 19th. So you still have opportunity to connect with the resource people and get your questions clarified. Mr. Sai Ramna, I think you can stop your screen share.
Yeah, ma'am, sure.
I now request and invite our chairman of PALS, Mr. C.N. Chandrasekharan, to come and kindly conclude the session for today.
Thank you,
CNC, over to
Sujata.
you, CNC. Yeah.
Thank you, Sujata. Okay. Thank you, Mr. Sai Ramana, for this electrifying session. Personally, it took me back 50 years when I started learning electrical engineering when I was in IIT. I think you came fully charged for the session, and nicely, started with the different grades of energy, high grade, low grade, merits and demerits, and talked about distribution, transmission, losses, and you all nicely interspersed with questions to make the students interactive, and you also talked about demand, losses, so many things, and about appliances consuming for energy, and I think you just grounded us all with such a detailed topic and very very relevant for today. As Ravi in the opening remarks said, how this energy kind of thing is the domain of energy is going to be the future, and everybody is talking about renewable energy and different types of energy. Thank you very much for this session. I am sure it will be useful for the students. One, from the point of view of their own course study in engineering. Secondly, from the point of view of pursuing a career in energy. And thanks to you all. It's now time to thank Deepan Kumar and Jayaprakash to be available. Again, as Ravi said, on a Saturday, coming and joining us, and with about 400 students and faculty, uh, getting benefit of this session. So next, I would like to thank faculty from our partner institutes for taking out time to join along with the students. And of course, the students who answered the questions and throughout the session, they actively participated, listening to you, and then finally asking very relevant and good questions. Thank you all. And I'm sure the further 3 sessions will be adding more information, more knowledge for the students' future and career prospects. Over to you, Sujata.
Thanks a lot, CNC. So participants, before you all leave, a gentle reminder, our next session is energy assessment on mechanical utilities, 19th September, and the session timing, 19th September being a Thursday, the session timing is between 1:30 p.m. to 3:30 p.m. It's our usual time. So I request all of you to ensure that you tell your friends, all of you log in and involve other friends from your mechanical department as well. So good luck to you see you on 19th. And to Mr. Deepan and Sai Ramna and Mr. Jayaprakash, thank you for taking our feedback from the session 1 and making this session as interactive as possible. Thank you so much. Have a great day.
Thank you, ma'am. Thank you to all.
Thank you. Thank you, CNC. Thank you, Ravi. And thank you, Ram. Ram was also there. Thank you, all of you.
Okay. Ma'am, I'll
Thank
stop
you,
the
Ravi.
recording.
Yes.
Thank you very much.
So I am allowing the participants to unmute. If any of you have any query regarding attendance and any other administrative stuff, please feel free to ask me now. I'll be around for another 7 minutes. Parameshwari, I don't know, it's a student or a faculty.
Ma'am, Tyagaraja College of Engineering Research Column.
Okay, ma'am, Dr. Parameshwari, ma'am, kindly,
Yes,
register and use